Hi there, and welcome to IV Tutor. In this video, we want to look at the merge sort algorithm. So we've already talked about the quicksort algorithm, and if you haven't watched that video, please just make sure that you do, because it's quite important that you do so. Right, so let's quickly talk about the merge sort algorithm. Right, so the merge sort algorithm works more or less the same way as the quicksort algorithm, except that, so in other words, both use the divide and conquer method. So they both partition the list and then, create sublists, and then they merge them together at some point. And the main difference, though, is that the merge sort performs better than quicksort always, because remember, the quicksort algorithm is a best case big O of n log n, whereas its worst case is n squared, which means it can get worse, or it can perform poorly sometimes. But merge sort is always n log n, which means it will always perform, it will always perform efficiently. But the main difference also on the partitioning is that, with your quicksort, we talked about using the pivot, and partitioning the list so that you've got a sublist with all items less than the pivot and another sublist with all items that are greater or equal to the pivot. And the other main difference is that your quicksort partitions sorts on partitioning, whereas merge sort sorts on merge. So some of the main key differences between merge sort and quicksort. And remember, we are not talking about the implementation detail of these algorithms. We are only talking about how to apply them in an exam sort of context, because you don't get questions in terms of how you implement these algorithms. You only get questions on how you apply them, given a list of items that need to be sorted. So for all these sort algorithms, you just need to remember how to apply them. You have to understand how the algorithm works. We are not bothering with the implementation detail, like if it's an array-based algorithm, or if it's an array-based implementation, or if it's a linked list-based implementation. So just to clarify there. But with the merge sort algorithm, what you do is it simply partitions the list into two sublists that are equal or nearly equal, and then after partitioning, it then merges them, and on merge it sorts. So the first step is if we just look at this, so the first step is to divide the list into two sublists, then you merge sort the first sublist. So by merge sorting the first sublist, it means you have to go and partition again that sublist, and then you merge sort that's the resulting sublist. And the first step is to divide, which means you're going to keep on dividing until you cannot divide anymore, and then you start merging, and as you merge, you sort. That's pretty much what's going on. So in most exam questions, they just want you to draw a tree to illustrate how the merge sort algorithm works, which is very easy, which means if you have a list that looks like this, you want to divide, and then so these numbers come here, these ones go there, and then you apply merge sort here, which means you then divide, and then you apply merge sort here and here, which means you then divide. So you keep on dividing, and then once you cannot divide anymore, you start merging, and on merge, that is where you start sorting. So that is how you simply apply it. You just merge, you just divide until you've got all these singular items. So you divide on both sides in a tree-like fashion, and then once you're done dividing, you start merging them, and as you merge, you sort. So it was 62, 48, and then now it's 48, 62, 30, 38, and then as you merge these ones, you also sort them. So in an exam scenario, you have to sort these on your own, in your head or on paper, but just make sure that as you merge these two, the resulting sublist is sorted, and the same goes here, and then the result is sorted. That's how you apply the merge sort in an exam, which means it's really easy. It's something you do very quickly. There's really nothing much to discuss on the merge sort. Let's look at another example, pretty much like here, where they say sort the sequence using merge sort. The resulting subarrays at each phase should be drawn in a tree-like fashion. So again, same concept. You have 10, 50, 40, 30, 20, 60. So if I merge sort these guys, I'm going to divide first. So you always divide at the midpoint. And a common question is, what if I've got an odd number of items? if you have an odd number of items, then the left side becomes the longer side. Just remember that the left side becomes the longer side, the right side becomes the shorter side. So if I've got 7 items, you put 4 items on the left, 3 items on the right. That's how you split. And then eventually you start merging, which means if I split this, in this case, it's an even number. So I have 10, 50, 40. So these go there. And then here I have 30, 20, 60. These go there. And then I divide these again. Now you see what I'm talking about. Now you have an odd number of items in this. You can see here, well, these ones were 1, 2, 3, 4, 1, 2, 3, 4. So these ones were all even. Okay, that's fine. So in this case, that's what I'm talking about. Now, if you split these, you're going to have 10 and 50 here. You're going to have 40 there. You split this, you have 30 and 20 there. And you have 60 there. Then eventually you split these, which means you have 10. And here you have 50. You split these, you have 30 here. And you have 20 there. And now you start merging. And as you merge, you sort. Now you merge these two. That means you end up with 10 and 50. You merge these, you end up with 20 and 30. Now remember, as you merge, you have to sort. And now you merge these, which means now you have 10, 40, 50 there. And then here you also merge these, which means now you have 20, 30, 60. And there you go. And then once you're done, you merge these two here into your final list. That means you have 10, 20, 30, 40, 50, 60. That's how you then merge eventually. So when you've done it like this, it means you have drawn your list in your tree-like fashion. So the merge method is really very easy to apply. If you just remember that I split. Once everything is split, then you start merging, and that's all. So I don't think I have a lot of examples. Oh, here's another one. Sort the sequence using the merge sort algorithm. Again, you're just applying exactly the same concept. You have 8, 22, 1, 4, 35, 3, 5, 7. So given this here, it's 35, 3, 5, 7. So you're going to identify your mid item. I've got 0, 1, 2, 3, 4, 5, 6, 7 divided by 2, 3, 0, 1, 2, 3. So I split right here. So in this case, I've got 4 items there. Well, in this case, I should split here. 1, 2, 3, 4, 1, 2, 3, 4. No, that's fine. 0, 1, 2, 3. Yeah, I've got 4 items, that's fine. So that means on the left, I'm going to have 8, 22, 1, and 4 there. And then on the right, I'm going to have 35, 3, 5, and 7. Like that. I split these. I've got 8 and 22. And here I've got 1 and 4. I split these. I've got 35 and 3. And here I have 5 and 7. I keep splitting. So now I have 8 here, 22 there. I split these. I have 1 here, 4 there. I split these ones. I have 35, 3 there. I split these. I have 5, 7 there. And now I start merging. So I merge 8 here and 22. I end up with 8 and 22. I merge 1 and 4. I end up with 1 and 4. I merge 35 and 3. I end up with 3 and 35. I merge 5 and 7. I end up with 5 and 7. Here, I'm merging these two. Then I merge these, I'm going to have 1, 4, 8, and 22. So as you merge, you sort. And then you merge these two here. And I'm going to have 3, 5, 7, and 35. So I've got 3 here, 5, 7, 35. So that's what I get here. Then eventually I merge everything. So it means I merge these two here, and I end up with 1, 3, 4, 5, 7, 8, 22, 35. And my list is sorted. So that's how you do the merge sort. It's not complicated. It's very straightforward. You need to practice, obviously, but I don't think there's a lot of pressure on this one. Here's another question which says both merge sort and quick sort algorithms sort or partition a list, right? Sort by partitioning a list. Explain how the merge sort and quick sort differs in the partitioning. So we said that the quick sort algorithm uses a pivot and it partitions the list by putting all items less than the pivot in one sublist and all items greater than the pivot in another sublist. And merge sort simply partitions the list by creating two nearly equal sublists, and that's it. That is the differences in terms of partitioning. And in terms of sorting, it's also worth knowing that quick sort partitions sorts on partition, merge sort sorts on merge. That is also another key difference. There's another question which says, which of the following statements about quick sort and merge sort is not true? Both quick sort and merge sort sort a list by partitioning the list. Yes. In a quick sort, sorting work is done during the partitioning of the list. Yes. In a merge sort, the sorting work is done during the merging of the list. Yes. To partition a list, merge sort selects an item from the list called a pivot. No, that's a quick sort. Merge sort and quick sort are recursive algorithms, correct? So D in this case becomes the only wrong answer. So that's it about merge sort. I think you just have to keep on practicing merge sort. It's not really very difficult to apply. You just need to practice. And that's it on merge sort. I'll see you in the next one. Cheers.